These are the answers for Unit 4, Multiple Choice Quiz B. First one gives you a probability table, a joint probability table for x and y, and asks you about independence between those two variables. So at first glance, it might seem like you have to do a lot of calculations to determine independence, but if you just do a little bit of observing about patterns in the table, it looks like every x value is multiplied by the same amount in every column. In other words, 4 times 2 is 8, 4 times 3 is 12, and 4 times 4 is 16. And that multiplication pattern occurs in every single y column. Going across the y's within each x, 1 times 2 is 2, 1 times 3 is 3, and 1 times 4 is 4. And again, that pattern occurs across every row as well. 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16. So since the patterns are the same throughout the entire table, the two variables are independent. And the reason is the value of x does not change the probability distribution of y. Within each column, the multiplication pattern is the same. So knowing something about x does not change the multiplication pattern within y. There are formulas for determining independence. In other words, the probability of A and B equals the probability of A times the probability of B if and only if A and B are independent. But you don't have to use that here because of the patterns that you see. So the correct answer is A. Second one gives you another probability table, and it asks you about the shape and the mean. And what you have to notice here is that this is a cumulative probability distribution table. So these should sum at the end to 1, which they do. So to answer this one correctly, you need to go backwards a little bit and undo the cumulative portion of the table. So the first cell is a total sum of 0.2. The second cell is the sum of the first and second. Well, if the first one was 0.2, then the second one has to be 0.3, et cetera, et cetera. If you find successive differences, you can figure out what the original probability distribution was. Plotting that quickly gives you a skewed right distribution with a long tail to the right, so that eliminates choices B and C. And then to find the mean, the formula for the mean of a probability table is a weighted average. Each value times its probability or its weight. 1 times 0.2 plus 2 times 0.3 plus 3 times 0.1, et cetera, et cetera, et cetera, produces 3.3. That's slightly less than 4, so the correct answer is E. Skewed right, mean less than 4 movies. Next one gives you 2 events and asks you about independence. So a little bit of vocabulary review. Independence means that this formula must be true. A and B equals the probability of A times the probability of B. This formula only works if you're told independent, and they are. But the first 3 options all talk about conditional probabilities. With independent events, conditional probabilities are mean that the first letter is unaffected by the second. In other words, the probability of A given B is just going to be the same as the probability of A. The probability of B given A is not going to affect B, so it's just the probability of B, and that one's not correct. And same for the third one. The probability of A given B in independent events means that B has no effect, so it would just be the probability of A, which should be 0.3. Those 3 are out, so now we go to the formula ones. Probability of A or B is sum the 2 probabilities and subtract off one of the overlaps because you counted it twice. Plugging numbers into that formula, A and B can be calculated using the gold formula up here because they are independent. 0.65, choice D. Next one is a much more complicated probability question because there are lots of little events going on within 2 different factors. So the best way to survive this question is to organize all the information that you're given. Each flight is going to be categorized as either early, on time, or late, and you're told that 15% are early and 25% are on time. The next sentence says 65% of the flights are overbooked. So flights are either going to be overbooked or not overbooked. That should be an O. Overbooked complement. 65% are overbooked. And then the last statement, 72% are late or not overbooked. Or statements don't show up in a table, so there's no place to put that. So when I go to find the answer to the question that they're looking for, we're going to do a little bit of summing of probabilities. Since every flight must be early, on time, or late, 15 plus 25 is 40, which means 60% are late. Since 65% are overbooked, that means 35% are not overbooked. And then to answer the question, late and not overbooked, I'm going to use a formula that involves both and or. Here's the or statement. Here's the and statement. You're given an and statement, so I can say, sorry, you're given the or statement. So plugging into this formula, reading numbers off the table or numbers that were given. The or statement is this. Probability of late is 0.6. Probability of not overbooked is 0.35, and we can solve for the probability of late and not overbooked. Doing a little bit of straightforward algebra, you get 0.23 or choice B. And finally, the last one, you're given two different probability distributions, one for W and one for G, and you're asked to find the mean and standard deviation for the total. So this question does not have a calculator icon up here, and I kind of find it hard to believe that they would expect you to calculate these standard deviations without a calculator, so I went and used a calculator. They both share the same input values, 0 through 6, so I put that in L1. And then the probabilities for W were put in L2, and the probabilities for G were put in L3. And then I asked my calculator to do two different statistics calculations. If you go stat, calculate, we want one variable stats, but we want to take the numbers in L1 and weight them according to the quantities in L2. So we don't use this second option all the time, but for this question we need it, L2. If I ask my calculator to do one variable stats in L1 and L2, I get an average of 2.98 and a standard deviation of 1.208 for the W group. Repeating that command, this time with the numbers in L1 and the weights in L3, we get an average of 2.3 and a standard deviation of 1.153. Setting up a little table, total for the means is just the mean of the first plus the mean of the second, 5.28, so that eliminates A and B. And then standard deviations do not add. You have to use what's called the Pythagorean theorem of statistics. Take the variance of the first plus the variance of the second and convert it into a standard deviation by square rooting those quantities. So 1.28 squared plus 1.15 squared, square root is 1.668 or 1.67, choice C.